All right, so in this problem, they're asking us to calculate the amount of heat associated with cooling down something. Notice they didn't use language like amount of heat released. If they did that, then it'd be a positive number. But they're just asking, hey, what's the amount of heat associated with the process? That means they're leaving it to us to figure out whether the answer should be positive or negative. I think the positive negative part we can answer very quickly. Since we're cooling something down, we need to remove heat from it, this 150 grams of water. So releasing heat, that's going to be a negative sign. All right, so calculating this, I'm going to show two different approaches. We're going to have, let me just show it on paper. Okay, so let's do option number one. We're going to just calculate everything in a normal way. All right, we're going to use two formulas here. Q equals mc delta T. This is for temperature changes. And delta T, just to remind people, it's the final temperature minus the initial temperature. And you have to follow this order strictly. Said another way, if you follow the final minus initial, then your sign, positive or negative on the Q value, will always be correct. All right. This second one is for structural changes, such as chemical reactions or phase changes. All right, this is an enthalpy equation. So we're doing a phase change here when we're freezing the water, right? So we're going to have this enthalpy value H. Sometimes people write it as a delta H. Most of my students are Chem 101 students, and I find that that delta there kind of confuses them sometimes. It's not as straightforward to understand as a change in temperature. Okay. All right. So let's lay out the work. All right. First thing to do is to cool the water down. We're starting at 25.60, and we're going to go to 0 Celsius. At that point, your water will freeze, and we're going to have to calculate the heat released from the freezing of the water. Okay, so we just wrote that step, and freezing is also known as fusing or fusion. All right, that usually makes me think of like jazz and music and stuff, but chemists and physicists sometimes use the word fuse instead of freeze. All right, and then third, we will cool the H2O, it's now ice, from 0.00 degrees Celsius to negative 10.70 degrees Celsius. Okay, so we're gonna calculate these Q1, Q2, Q3, and then add them up. Let's see, they want it all in kilojoules. So if the answer doesn't automatically come out in kilojoules, you're gonna see me manually do that conversion. All right, so let's do these one by one. Okay, so we're going to cool down the water, liquid water, from 25.6 to 0. So I like to calculate my delta T's immediately. Our final temperature is 0. And we're starting out at 25.60. So that means we're going to have a negative 25.60 degrees Celsius as our delta T. Okay? All right, so plug and chug. 150.3 grams. All right, and we need the correct delta T, or excuse me, what do we call it? How come it's not? Hang on. There it is. The figure went away. We need to see the specific heat capacity for liquid water. .184 joules over grams degrees Celsius. And then our negative 25.60 degrees C. Okay, let's see what survives the unit apocalypse. Grams, degrees Celsius are both gone, so we're going to be left with just joules. All right, let's put this in the calculator. All right. Let's see if we can remember. There we go. -6. All right, and then sig figs 4, 4, 4. So we'll go up to there for sig figs. Okay, and we could rewrite that as. Oh no, we'd have to go there. Scientific notation. I don't feel like scientific notation. Let's see if we can get lucky with avoiding scientific notation by going to kilojoules immediately. Okay, so we'd have negative 16.10. Nice. I was able to avoid scientific notation by converting to kilojoules. Not feeling the scientific notation this morning. All right, next. Let's do Q2. And this is going to be our freezing, so we need the moles and the enthalpy. Oh, we don't have the moles yet, so let's go ahead and solve that. Oh, my face was covering the work earlier. There we go. All right, we need the moles. Let's get the moles over with. Let's see, 150.3 grams times 18.02 grams over 1 mole. We're talking about H2O here. 8.341 moles of H2O. All right, now we can plug that into this equation. So we're going to have, let's see, 8.341 moles of H2O. Okay, 4 sig figs. And then what is the H of fusion? Okay, 6.01 kilojoules per mole. Okay. Now, you're going to need the negative version of the enthalpy value because if you are freezing, then you need to release heat in order to freeze, to slow down those hydrogen bonds, to lock into place as solid ice. You need to release heat. So it's on you to recognize to put the negative sign there. So remember, enthalpy value, keep it the way it is if you're adding heat. If you need to remove heat, you have to do a negative sign. Or you can just add a negative sign to whatever your answer is if you're removing heat, making something colder. All right, I can just use this previous answer already in my calculator times, well, some of you round it on the spot. I'll just do the same as you. All right, and now, nice thing here is that our answer is already in kilojoules. So we don't have to go out of our way to convert, but our moles will cancel. Okay, so we get, what do we get? 50.1 negative kilojoules. Okay. And only 3 sig figs there because part 2 to calculation here, after we got in the moles, we only had 3 sig figs there. So if we were to add these two up, the answer would end in the 10th place, the last digit. Okay. And then let's go ahead and do third calculation. Need a paperweight. How about this tungsten cube? That should work. Q3 All right, we're cooling down something. It's a temperature change, so we need this again. All right, so the mass of the water, we can just use 150.3 again. Specific heat of solid water, aka ice. So we don't use the 4.184 this time, okay? The heat absorbing behavior of water changes when it's ice, okay? With a specific heat of 2 versus 4, solid water, ice, is easier to heat up or cool down. It doesn't take as many joules, does not take as much energy. All right, and then we're gonna have a delta T, and I'll do that in advance. We're going, we're gonna end at negative 10.70, and we start at 0.00. So that's just going to be degrees C. So that's just gonna be negative 10.70 degrees C. So we can just plug that in. All right. 4 sig figs. But we need to turn this into kilojoules. And there is our answer. All right, and but they wanted the overall amount of heat released in the process, so we will do a Q total, and we'll do a nice color coding here. And we just add these all up. Okay, so we had a negative 16.10, and then 50.1, and then a, what was it, 3, oh, it's right there, 3.364. Okay, so sig figs, they're going to end in the 10th place. Okay, I don't feel like doing this in my head or on paper. All right. Negative 69 point, that will round up to 6 kilojoules is our answer. Okay. All right, let's see if the app likes it. Sweet, and we even got the sig figs right. All right, so yeah, that's one way of approaching it. The other way I would have maybe approached it, if I can find the other way I would consider approaching the problem is you could pretend that you're calculating everything in a heat absorption sort of way. Okay, let me write out what I mean by that. Okay, here's the other method. I'm not going to show this in full detail, but some people have an easier time thinking in positive numbers. So what we could have done is we could have pretended that instead of cooling down water into ice, we could have done the reverse. We could have pretended that we started with a block of ice and we started at negative 10.70 Celsius, and then we increase the temperature all the way to 25.60 Celsius, melting the ice in the process. You calculate all of those, you add them up, and then you add a negative sign at the very end to your total. You would get the same exact answer. So whatever makes more sense to you. All right, hopefully this helps, and let me know if you have any other questions. Thanks. Take care.